AI is such a polarizing topic when it comes to software engineering. Like on one side, you have engineers who think AI is just writing garbage. It's trained on legacy code, there's no craftsmanship, no discipline, it's just autocomplete on steroids. And on the other side, you have engineers who are having so much fun with it. They feel empowered and they really think it's the future. But there's a third group of people that nobody's really talking about. And these are software practitioners who spent decades teaching software craftsmanship, and they looked at all the things AI can do and thought, what if we don't just let it freestyle? What if we take everything we know about good practices from product management, from agile, from software engineering, and we force the AI to follow the same processes we've been using successfully all along? That's exactly what today's guests built. So what if AI could deliver code so clean, so well tested, that rework just disappears? Hey everyone, welcome to the Product Engineers podcast. This is Pepe, your host. Today's guests have a combined 60 plus years of software engineering experience, and they used all of it to build a framework that forces AI to write code the way a senior craftsman would. We have Michele Brissoni, who is the founder of BrickX Consulting and a fractional CTO for Fortune 500 companies. He cut his teeth in behavioral engineering at Ferrari Formula One during the Schumacher era, invented the Software Craftsmanship Dojo, and led a DevOps transformation at IBM across 15,000 people. He also hosts the Forge of Unicorns podcast, where he ran over 80 episodes with the people behind 52 unicorn companies. We're also gonna hear from Marco Consolaro and Alessandro Di Gioia, who are two software craftsmen, technical coaches, and co-founders of Alcor Academy. Together with Pedro Santos, they co-authored the book Agile Technical Practices Distilled, a multi-award-winning book on TDD, refactoring, and software design. They've been teaching outside-in development and software craftsmanship at conferences like NDC, DDD Europe, and DevOps Days for years. Michele, Alessandro, and Marco have been building together nWave, an opinionated open-source agentic AI coding assistant framework that infuses every line of AI code with 2 decades of engineering discipline. Want to know more about it? Let's get into it. Welcome to the podcast, Michele, Alessandro, and Marco. It's great to have you here. I'm so happy that I have the opportunity to interview about nWave today. So before getting into the, what is nWave and how it can help software engineers in the era of AI, question for you, Michele, because I know you've been quite involved in the development of this tool. Could you maybe take me back to that specific moment when you realized that AI coding tools were kind of making the industry a bit worse rather than better? And what were you looking at? What was broken?
Okay, great question, because we jump back of, I guess, something like 7 years. The first tools that we saw were saying commercially that were bringing AI into the software development lifecycle were in 2019. And so we were starting to experimenting with Tab9 and Kite. And in that tools, we realized that something was on the edge to change in software development. The tools were still embryonals, were still not mature as they are now. If the meter of maturity could be today cloud code, they were really something that wasn't even AI, in my opinion. It was more pattern recognition, so it was more data mining or patterning code base that were providing you some hints about, hey buddy, you should change this code from this style to that style. This was the moment where we realized, okay, AI is coming to software. And since then, we have started to understand, okay, how AI and machine learning is and will change software development forever. Then, as we know, in 2023, we got ChatGPT, and everything got a hyperbolic speed since then. And today, we are discussing here about nWave that we have spent last year with Alessandro building it, but we will go into the nitty-gritty details about nWave later with you. But that was the moment, and at the beginning, I tell you honestly, Pepe, we weren't impressed at all about these tools. They were far behind from the literature of proper craft and proper clean architecture or clean code. But still was an interesting moment because it was the pivot in the industry.
So you said you were not impressed by this new technology at the beginning. What was that moment that really started to make you think differently about this? That said, okay, now things are actually changing.
At the beginning, only with ChatGPT because it was the unique tool available. Because we felt that, okay, we are even going in the wrong direction. So it's even less accurate. And so at the beginning, we were really skeptic, but aware that it was a moment because this was a disruptive event in the industry. And so we started to explore about this technology with open mind, with really research and development mindset. And we have tried to do a autopsy of how code was built with this LLM to a point that, as I wrote in some old articles on my newsletter, with Ale, I took even the idea to start to measure the amount of swearing I was shouting to LLMs because they were drifting every time we were trying to do something in the wrong direction. So that we have started to develop early in 2024, roughly, a system that now we know everybody is called the compacting system. So every time the LLM was starting to drift, we were extracting the context, cleaning from the dirt, reinjecting the context in a new chat, and then restarting from almost scratch. This is where with Ale we start to understand, okay, it's not yet on the right direction, but then finally arrives Cloud Code, a lot of competition with other providers from DeepSeek and all the other Meta, all the other Gemini, all the others that we have on the market. And then we start to see improvement at speed of almost weekly cadence until last year, finally we got all the technical infrastructure to build what is inside nWave, thanks to a genius invention from Alessandro. But I let him discuss about this.
So we're gonna get soon to how nWave works. I know that you all have a lot of experience in the industry, like more than 20 years building software. When you started building nWave, is there one specific lesson that from your career that you really wanted to bring into nWave, that something that you would never skip?
It's interesting because it reconnects also with the question before, right? The bottleneck is always upstream, right? The business people blame the developers because they take forever. The developers blame the business people because requirements are unclear. And then we are stuck in this situation. So, how you unblock? Well, of course, first we say, let's be humble. We can improve the way we code, right? And so let's make the first step. Let's improve as a technical team and show them that we are able to move on and be better. At that point, the bottleneck is clear back in the business side of things. And, the idea here is, I told Alessandro, we cannot do something just for code. We need to do something that helps the entire software development life cycle. Because if we don't resolve the bottom upstream, doesn't matter that the AI is a crafter, because if you give them bad requirements, it's a bad product with amazing code.
Okay, so I guess maybe it's time to get a bit more practical about nWave. So let's see how it works into practice. And I would ask this question to Alessandro because I know he's been one of the early adopters. So for someone that is listening and never worked with nWave, if you could walk me through what happens from the moment you have like an idea for a new feature. So from this moment to the moment it's deployed to production. So how does the whole process looks like?
Okay, so thank you for asking this question. It's going to be almost like a virtual tutorial, but brace yourself. Okay, so the idea is, like Marco and Mike mentioned, it doesn't matter how good you're implementing something if it's useless. Okay, and so understanding what matters and why it matters is crucial. And this is very related to the history of nWave, because one of the first agent and commands that I implemented is the research command and the researcher agent. Okay, it was the real first agent, and the reason is because AI hallucinates, and publicly available information is unreliable. So you have two sources of unreliability that you have to handle. And so my idea was to create a command, which basically it's an instruction for the main agent, the one you interact with directly, to set a set of rules for what a good research looks like. So how to choose your sources, how to balance what you find. Okay. And so the researcher, it's an agent specializing in researches, and the research command is the prompt, if you want, that the main agent use as a template to instruct the sub-agent on a proper research. Then there's another command that is very important, which is the review, nW review. All of the commands and agents start with nW so that you don't have conflicts with other commands and agents or skills that you have installed in your systems. And the review command, it's one of the other crucial tools that you have to master at the beginning, whatever you're doing. The reason is because the AI, again, hallucinates. And so it can, even if you write everywhere in its memory, in its Claude.md, if you're using Claude, or anywhere, that it should not say something that is not true or backed by facts, eventually will do because of context drifting. Okay, in fact, we can think of the AI memory as a U-shaped. So it remembers the system prompt, so something that was embedded by Anthropic, for example, and then the last things you said. The thing in the middle become less important. And on top of that, it loses attention at the end of a document. And so if you say, okay, find me these patterns, it will trigger more often at the top and less often at the bottom. So these are all things that you have to take into account when you're dealing with AI, because when they say it's non-deterministic, it's true. But what are the effects of this non-determinism? And so the research, it's a way to say, well, when you're finding a piece of information, don't stop there. Find also, if you can, counter evidence. So that will balance whatever information you will find. And when you're applying the review, we call this adversarial review. Okay, I don't like adversarial stuff, even though I like Kung Fu, practicing Kung Fu. I'm a martial artist like Michele. But the idea is that this comes, if you want, from some research of behavior engineering by Mike, but also from our experience in dealing with teams when we are dealing with, lack of trust. Okay, so a good team, if you read Patrick Lencioni, 5 Dysfunctions of the Team, it's a team that can keep each other accountable. If you can keep each other accountable, that's when you can trust each other. If you trust each other, you have a healthy environment. If you have a healthy environment, there's a cascade of good effects. I can't stress enough how important they are. And so these are very humane activities that are crucial to translate into the machine, because the machine can scale these activities. And so the review, it's basically another expert as the agent you used with the same background and knowledge, but with no context. So there's no biases about the previous research. And in the review command, the prompt is actually mentioning, actually you can call that explicitly if you want, make a radical candle review. So like use this specific style of reviewing to basically tear apart whatever the other agent found out. And many, many times it finds defects, imprecisions, even lies. Not that often, but sometimes it happens. So why this matters? Because in this way, you can drop drastically the inaccuracies. And we did this way, way, way before a white paper that just came out that proved that this is actually a good strategy. So empirically, but also humanely, we find out, yeah, you know what, if you have an expert, as you are, that comes and have a look at your code or your decisions, they are going to find things that you won't find. This happens whether you're using AI or not. And so that's a humane good practice that we brought into the code. Now, why this matters? It matters because this is the first step. So we have different waves, okay? If you want to, so why we are using these waves instead of phases, okay? Because the idea is that what we're doing is human-centric, okay? Since it's human-centric, there's a continuous moving back and forth of the interaction. That's why it's waves. So let's say that, as you were saying, you want to introduce a new feature. And I can't stress enough how nWave expects you to develop in cycles, small, repeatable cycles, no big spec upfront of the whole project. That never worked, it will never work, okay? Why? Because software changes and your perception of the software changes over time. I want to state this clearly. Okay, so we are not spec driven. We are beyond that. Okay, we are feature driven. Actually, I like what Andrea Laforgia, one of our friends, it's an early adopter of nWave, suggested, which is expectation driven. Okay, so we have expectations. How do you get these expectations? Nothing new under the sky. First wave is called discuss. Okay, actually, if you're starting really from scratch, there's a zero wave that it's called discover. Okay, that's for the discovery phase. You know what the discovery phase is. You have to do research and interviews. That's where that waves can help you. But let's think that you just want to introduce a new feature in our software. Okay, so you start with the discuss wave. In the discuss wave, it's basically a brainstorming where you interact with the AI and start explaining what the new feature is all about. And the AI, which with this command will trigger the agent product owner, will ask you some questions, okay, about the scope of this, if it's UI facing, if it's a backend, if it's cross concern, all these kind of things. Why? Because there's also part of the lean UX embedded in the product owner. And this is a real contribution from Mike straight away to introduce this attitude into the discussion phase to find out what are the things that you want to implement. And if you also require, for example, a jobs to be done analysis, it will derive what is the value, what is the pain point, what are the the pushes, the pulls, and the friction of a new feature. And you can do that also retroactively. So let's have a discuss about the features we implemented in the past without nWave and find out what are the problems they are solving, or if the problems they are solving are actually still underserved. The other part of this discuss phase is that it shows the user a whole emotional journey. And so it will create a graphical ASCII representation of a graph of how a person interacting with the new feature will feel. And so again, you can already think that, oh, I'm using an AI tool But the needs of this person are so central that the first phase starts with, what are we doing this for? Or for whom? Okay. Everything starts from this. Now, there are situations where you don't need this. If you are bug fixing something, or if you are quickly creating an MVP, you don't have to go through all the ways. But it's up to you which one you want to skip. Okay.
Yeah, I will say business people, product owners, business analysts, have a look on nWave because you might find something for you as well in there.
So before getting to the next wave, so you were speaking about emotional journeys, which I suppose they require some knowledge from, like, on who is the user and who they are, like maybe the typical user persona, let's say. How does this work in practice? So do this course requires you to give this information?
I let Mike answer this one because I see him boiling, and this is his his contribution to this agent. So go, Mike,
A
unleash.
little baby. Yeah, thank you, Ale. So the product owner Luna is designed to work user-centric. And Luna is designed to create the user persona, so to have the maps of your users, to understand which kind of needs they have, to create a journey that is emotionally compliant to what they need to achieve. In the enterprise version that we have improved with more agents, there is even an agent, Giotto, that is creating even the user experience with the user UI combined together, so that the graphic aspect and the emotional aspect are exactly helping people to do what is supposed to do. As Ale said during the presentation of the first wave, in nWave we put all the research we have done in the last 2 decades about behavioral engineering. Since I was working, thank you to my brother, on understanding how the Ferrari F1 team in the era of Schumacher, they were working on the field. And what I discovered was that wasn't only engineering mastery, but was also behavioral science behind it. Behavioral science that also is confirmed is the secret sauce of Fabiano Sterlachini in now taking over Aprilia Racing and MotoGP. And so you see two fields that are maybe parallel, so Formula One and MotoGP, very orthogonal to software, but both of them, they use a very large amount of software behind the scene. And all the electronic, all the aerodynamic, a lot of stuff is based on software, all the simulation. And I observed them, I understood how they were working, I synthesized the practice that they were doing without probably even knowing that it was behavioral science, and I started to study it. Then with Al and Marco, we experimented them in the dojo to enhance training with behavioral science, to get more information retaining for students, more gamification, more gratification. And this went mixed together with Lean UX, since it was released in 2012 to today, what we know is design sprint. So all this together went inside Luna, and we released open source to create this need for software to be user-centric, to join finally together product and technical people, so that they work as a tandem, not as a silos that I provide you the handover of the requirement, implement it with AI, because this is not how it is supposed to be. And so we knew, working since the XP days in the early 2000s, that having a product owner, a man in the middle that can filter conversation is suboptimal. If you should have the customer on side, it would be a lot better. So we have tried to create a infrastructure with nWave that facilitates this, that helps product people and software people to work together with the customer. And this is what we have built inside the product owner agent. in a way that now the agent will ask you a lot of questions. So the other day I was working with some stuff with Ale, and I told Ale, give me a second, I have 50 questions that I have to reply to the product owner.
I just want to mention that there's an aspect in the product owner when dealing with the discuss phase that it would also recommend some KPIs, and they are going to be crucial for one of the following waves because they are going to be implemented as part of the feature so that you can actually automatically create the infrastructure to measure the impact on the behavior of the users as expected. So it's not only about describing the feature, understanding better what the user needs are, but also being able to evaluate and measure that the feature actually is delivering the value you expect.
Okay. So the product outcomes.
Exactly.
Alessandro explained how the discuss wave is about understanding what you're building and for whom before writing a single line of code. The AI acts as a product owner, asking you questions, mapping the user's emotional journey, even suggesting KPIs to measure whether the feature actually works. Now, the next wave is where all of this gets translated into architecture. Let's get into it.
So this is a crucial step, the next one. I would say it's one of the ones that you should rarely skip, and it's the design phase. Okay, we call it design, but it's basically all about micro and macro design. So the architecture in the large, the architecture in the small. And this is really, really important because it's where we are start translating the human needs into software solution. So the architect will will ask you some questions, especially at the beginning when if you're starting from scratch, on the style of the architecture that you want, on the paradigm that you want to apply. So if you're working in object-oriented software, it's different from functional programming. Okay, and this becomes a driving force for the future implementations. And it's able to understand not only the local architecture, but also cloud and distributed architecture. And you can even extend its knowledge. Let's say if you want something that is really, really, really specific to I don't know, Google Cloud instead of Azure, then you can basically unleash the researcher, gather information about patterns and knowledge of Google Cloud, maybe taking inspiration from the existing knowledge on Azure, and ask the builder to create a new skill for that thing. The idea is that the architect is going to be not a ivory tower architect. Okay, this is the kind of architect which is just an aspect of a technical craftsman that is dealing with product delivery in a multicultural team. Okay, so the idea is that we want to make architecture matter, but we want to try avoiding, siloing these roles. Everyone should be able to understand and talk about architecture, of course, with different level of competence. And so this architectural part, it's where it asks you, okay, do you want to start small, or do you know already that we have to handle 10,000 requests per second per node, anything like this, because it changes very, very much the approach. And the cool thing is that you can, over-engineer as much as you want, which is good and bad at the same time. Why? Because our recommendation is to create a modular architecture that can be scaled gradually over time, and the agents will help you in doing that, especially if you say, okay, we don't know yet, so let's start small, but let's put in place an architecture that will be able to scale eventually. And so maybe the solution architect will say, okay, let's start with a modular monolith that eventually, once we have more information, we can split into something that is partially monolithic and partially distributed, okay? Instead of starting straight away with an ecosystem of microservices. But if that's what you want or need, the agent is capable to give you this recommendation. Of course, the agent will also produce quite a lot of documentation, which is not just to burn more tokens, I would say. Okay, so that documentation, it's actually a snapshot in time of what is your understanding of the needs for your product. And the architect will produce many documents, the architectural design records, together with diagrams for you. So the C4 diagrams, it's embedded by default. You're going to find out that at every feature is going to try to, I would say, extend the design you have with the new feature. We spent quite some time reminding the architect to be able to try to avoid, for example, reinventing the wheel. So it will try to look for open sources projects that can help us speeding up the development because they're already in place. Try to extend the existing design, so not rewriting the same code, it's just slightly different. Okay. On the other hand, it's also your job to make sure that this happens. So my recommendation is, remember, it's waves. Don't take any outcome at face value, and especially don't take the first version as correct. At least give it a review, possibly more than one. Continue refining until you feel confident that that's the right direction. Okay. If you leave it to interpretation, assume it will be misunderstood, just as it would in any human interaction. With the machine, it's kind of worrying because we have a tendency of underestimate what it can do. And I can tell you that it's very creative at exploiting gray areas so that it works less and can burn more tokens. Okay, so it's a super powerful tool, but you have to understand that it's a tool that has drawbacks too. Okay, so my recommendation, which is embedded in the name, is it's a wave. It oscillates back and forth.
Let me add something here to what Ale was saying, Pepe. This phase is for us also very critical, and indeed we have two agents that does the design. Because we have the architect, but we have also the platform engineer that applies all the SRE workbook from Google and all the DevOps knowledge to being able to understand after the discuss phase if the infrastructure for the design made up from the architect is congruent with the best practices of cloud native, of observability. So the KPI that we were looking as product then need to be translated into the infrastructure so that we can observe them. So all this is a phase, as you see, that has two agents with two reviews. And this is very important to make, especially at the commencement of the project when it's greenfield, or when you get some legacy code to create the baseline from both perspectives, because this is the part that is the one with the greater majority of AI creativity, because we don't have test yet in place. It's not code. And this is one part that with Ale we have tested with many angles. Having two agents that they fight each other was a good balance. But this is indeed the most delicate phase when you start a new project, because you can put it in the right direction or slightly curve in the wrong one. And then it will help you to understand in the future, oops, I need to go back and do some rework. And this is why it's so important to interview at least 2 times here.
Right. So just to follow up to this, how did you make sure that the output of these two design agents is balanced between what's useful for the agents of the future and the developers of the future?
So with Ale, we got two stuff going on as experiments for multiple months last year, and was one, we need to stop what we call test theater, and it's something that we will discuss when we will check the phase of delivering the code. The second instead was to create a sort of behavioral guardrails of the agents so that they cannot cheat. The idea was we need to being able to rely on the agent with a variability of their behavior, so the expectation, as Andrea Laforge created this new trend of expectation, so that we expect from the pair, that is Ale or the agents, that they behave with a certain degree of variability. And so, test after test, we were able to narrowing the behavior into a variance that is acceptable. And now, indeed, these agents, they are behaving as a normal human being, of course. It's a virtual normal human being. That means their stochastic nature is creating some variance in the output, but the guardrail that we have put with behavioral engineering to frame them are so strict that they cannot do that much of variance. And to be more specific, we treat the agents with prompts that are telling them, you have to do only this. And we have created them as solid, so with the S of solid, so with single responsibility. They have only one reason to exist, and they have to do this. Then Ale created, thanks to the cloud triggers, a deterministic execution system that is called DES, that is obliging the orchestration of the agents to being specific to some patterns that we call it contracts. So we are applying contract testing in how we invoke and summon the agents. So we know that the input has to be compliant to a prompt that is as a contract. Then the work is frame of behavioral guardrails. And then the output needs to be compliant with a document that is the memory of what the agent did. All this memory are the context of the agents for the next waves. In this way, we have normalized input, behaviors, and output. And all of this is under DES, so it cannot be exploited from AI. And AI tried to exploit it many times. With Ale, we found interesting patterns to a point that Ale was able to say, okay, let's do the audit of what they do, so that we use the audit of the exploits to improve the guardrail itself. And so for months, we have worked with the DES in alpha, and the DES with the audit help us to understand which new guardrails to put in place. But this is really something that I would love Ale to go into the details, because he's little baby. So I put the behavioral science, but he put all the brain and the fingers on the keyboard to build it.
So after discuss and design, you've got clear requirements, a solid architecture, and reviewers that challenge every decision, all before writing a single line of code. What comes next is where nWave actually starts building software. By the way, if you're finding this episode valuable, I would invite you to subscribe to the channel or follow me on your podcast platform so you don't miss future episodes. Now let's get into the delivery wave.
So before the delivery phase, there are a couple of phases that I recommend you to look into. One is the DevOps phase, which is the one that puts in place very quickly the continuous integration pipeline for you if you need to, local and remote quality gates. It's also the one responsible for creating and designing the infrastructure for the KPIs. Okay, together with the architect, we call this platform architect. They complement each other in the idea of having a full-fledged system. Then there's the next wave, which is very, very important, and it's becoming even more important now with the new releases of nWave, which is the Distill phase. So the Distill phase is the real moment where you are moving from the humane world. Okay, so all the design, all the requirements, if you want, are being translated into code. How? Not by writing code straight away. So the distill phase is the phase where the agent is instructed to write the acceptance tests that are going to fail until someone implements the logic to make them pass. So this is known as the double loop of test-driven development, or the acceptance test-driven development, but with the flavor of London School. And so from the outside, so it's the outside in acceptance test-driven development kind of flavor of test-driven development. Why this matters? It matters because the acceptance tests are going to be written by one agent, and some other agents are going to make them pass. So no cheating. Those are the expectations we have. These acceptance tests are going to be reviewed by the previous agents. So you have the acceptance test designer, which I would say it's basically what we call the quality engineer. So the quality engineer, it's an expert in the domain that takes all the requirements as before and translates the requirements into executable tests. Okay. Then the product owner, the solution architect, and the platform architect are going to review these acceptance tests to say, yes, you have the qualities that we expect from these tests. No, they're testing the behavior, they are not testing the details, they are respecting the design mandates and the scope and all that.
So before any code is written, nWave has already set up the CI/CD pipeline, the observability infrastructure, and a full suite of acceptance tests. These tests are designed to fail until someone implements the actual logic. Think of it like building the finish line before running the race. The AI knows exactly what done looks like. Now comes the delivery wave, where the AI finally writes the code. And this is where all that upfront discipline really pays off.
The deliver wave is when the magic happens. Why? Because that's when we are producing software. And our hope, our ambition is to automate the vast majority of this as much as you can. Okay, this way you can focus only on reviewing the final result very quickly, because AI burnout, it's a problem. Okay, now that it's cheaper to code, you are doing it more, not less, and that takes it's taxing on mental health. So I'll let Mike discuss about this a bit later, because this is an important topic that he's been investigating. So by Marco's pushing others by saying, people, you have to also take a break sometime, otherwise there's no next. So what happens? So what happens in the deliver wave? The deliver wave, it's a prompt, okay, that is invoked, loaded by the main agent to instruct the sub agent on how to do the work. How does this work? So there's going to be the architect that is it's about to write the roadmap. The roadmap, it's basically the execution plan. Okay, so it's a JSON file, not an MD file. So this is for machine eyes, if you want, first. It's a JSON file where step by step, there are, I would say, atomic implementation steps for the sub-agent. Why they are atomic? Because of context drift. And so the main agent is instructed to invoke one new instance of a sub-agent for each new step. Each new step, it's a round of inner loop test-driven development. What does it mean? It means that each step has an acceptance test that fails. The job of the agent is to write unit tests that fail first, then make them pass, so that when they pass, the acceptance test pass. Okay? And so basically you have a verification from the outside that values the outcome. Okay, something useful for the user happens. Internally, there's this agent that writes all the unit tests required to make that behavior happen. When this happens, it's committed, and then a new instance is created. But as Marco and Mike were saying before, how many times, how many hours did you spend swearing at the AI that even if you're writing in stone, oh, please write the test first, then make them pass. Don't write the whole code in one go. Don't respect these principles, and so on and so forth. Eventually always end up with, sorry, you're absolutely right. I made a mess. Let me fix it, making it even worse. Right? That is known, as we know already very well, context drifting. That's when the DES system, so the deterministic execution system, comes into play. So deterministic execution system, it's a set of hooks that Claude Code allow the user to plug into, and they are triggered by some events. For example, when you are invoking the subagent. And so how does this work? Okay, it's no secret because it's open source, so I'm going to say it out loud and easily. Basically, what happens is this. The main agent is invoking the subagent with a prompt. That prompt is the execute command. You can even invoke it yourself. When invoking the subagent, the prompt has to have a specific format. If it doesn't have that format, the hook stops the agent and say, no, this doesn't work because you're missing this, and this section. So basically, it's fighting context drifting, reminding the AI what is the right way to invoke the subagent. The subagent has no context because it's a new instance every time. And so this allows us to make sure that the subagent does a good job because, the U shape, it's not even getting in there. Everything, it's at the beginning of that U shape. And so it gets a lot of attention. That's why the roadmap has to have small, many steps, because each step is going to be implemented by a fresh instance of a new agent. Okay? And we make sure that this new agent is invoked in the right way because we have a algorithmic software system that intercepts the call and fixes it. Of course, there are other checks in place as well, especially for performance and compliance right now that we are going to expand for the enterprise offering, which are auditing the decisions that were taken and the execution with which parameters and so on. In this way, we want to allow the usage of this tool in highly regulated context. But the basic idea is that we instructed the crafters, the software crafters, with all the knowledge that we accumulated over the decades. As you know, Marco, Michele, I have been teaching this stuff for years. Okay, I don't want to look arrogant, but we have been into situations where technical excellence was the difference, and it still is, whether you're using AI or not. And so basically nWave, and especially the software crafters of nWave, are the culmination of decades of working on the field, knowing what works better and what doesn't work that well. You can disagree with us, that's absolutely fine, but at this moment, the only thing that I've seen working better than writing all that automation myself is having an AI doing that for me. And that's exactly why nWave exists. And then at the end of the delivery phase, there is a massive review phase where at the end of the delivery of a feature, you will still have a review of all the work that has been done, a refactoring. So we put in place what we call refactoring priority premise, which is a concept that we came up with in our dojo, which is the usual refactorings we all know, but done in a certain order, because following this order allows for deeper refactoring to be done more easily. For example, first, remove repetition before introducing a new type. Otherwise, you have to introduce the type all over the place, which is doable for humans, it's doable for machines, but it's wasteful, and sometimes you can lose a spot. Same thing for AIs. So modular, well-written code, it's not only for humans, okay? After this, it's going to be committed. And that's when, for example, you can have a look at the code as produced. I wouldn't recommend to have a look at the code as produced on each of the steps of the roadmap, because it's a too small portion and it's going to break the rhythm. Instead, I would recommend to have a look at the code once the feature is deemed to be complete, so that you can have a better understanding of how many files have been written, how many tests, and have a better understanding of what's the big picture of that feature. Because if you're doing it too often and too small, you lose the bigger context. If you don't do it often enough, for example, at the end of the feature, then you lose contact with the code base, which is also not helpful. Instead, you need to maintain a balance to keep yourself sane, but also understanding what's going on. And then at the end of this, depending on your configuration, it will try to run a round of mutation tests on the file that have been changed. Why this matters? I always recommend having mutation tests active in different formats. So if you're working, let's say, with C, Rust, so things are very quick, you can have the mutation test run at the end of each feature, but it's time consuming. So the other recommendation I give is to have a nightly diff mutation test, which basically takes all the files that have been changed today, and during the night runs the mutation testing against them. Even if it takes a couple of hours, you will wake up the next morning with the missing blind spots in your test, okay? And then there's the last part where it's running a quick retrospectives, okay? So it's going to look backwards at the implementation and find out what went well, what went better, what went bad, and what went worse.
So that's the full nWave loop. nWave starts by understanding what to build and for whom, then it designs the architecture, then it writes the tests that define what done looks like, and only then the AI starts writing code in small discipline steps, with importantly fresh context every time. At the end, it also runs a refactoring session, runs mutation tests to catch blind spots, and even does a retrospective on its own work. It's basically 20 years of software craftsmanship automated. Now, the obvious question is, doesn't all of this makes you a bit slower? Thank you very much, guys, for explaining how nWave works end to end. I can definitely say you put a lot of thoughts into it, and it seems like a gold mine of all your experience packed into this cloud plugin for now, right? It makes me think about something that my professor of software engineering told me at university when he was teaching us object-oriented programming. That OOP, it's like giving ourselves a kick in the balls because it kind of gives us discipline, right? From like procedural programming, and it could be more time consuming because you need to design everything. And nWave, in the same way, seems like a way to provide discipline to how software is built. So I can imagine someone in the audience can think, well, okay, now we have all these practices that are enforced into nWave and all these guardrails that you put in place, right? And some developers may think AI was supposed to make me faster, but now I have all these things in place that could kind of slow me down. How would you respond to them?
Okay, let me use a metaphor. AI, okay, it's like a train. I'm not building guardrails. I'm building railways. Okay, a train without railways, it's only, digging holes faster standing in there. right? So it's how is it going to make you faster? So it's slower than not doing these practices, but there's no rework or almost no rework in what you're producing, which is a massive, massive return on investment, because you know that once it's implemented by the AI, you at most have to put 20% of the effort, which basically means that the thing that we have been seeing is that you can deliver a feature in a matter of 1 or 2 days instead of 1 or 2 weeks. If this is still not good enough for you, well, I want to see what you can do with your current practices. But the thing that I've seen is that if you want to automate more and go faster, you have to create an environment where automation is possible. I mean, even in the past, in the old mines, if you don't build the railways to bring the cart outside, you have to do that manually. And you can have many people doing that, or have less people, but you have to adapt. If you call it discipline, I don't know. To me, it's like you have to create an environment where automation is possible.
I would add something on this, right? Because it's not only the speed of AI, right? We are moving from walking to railroad, right? So do we really need the bullet train where we don't know where we are going? We hope that it goes in the right direction. Or we can say, okay, let's take an intercity, but we are sure that we are going exactly where we want, right? Which one would you choose? Here, the problem is that the single main thing that slow down teams is rework. Okay, that is the problem. We need to eliminate the rework even before the AI. The goal was to eliminate rework. Why do we do tests? Because we want to trust our code does what we think it does. We need to ensure the ergodicity of our system somehow. Otherwise, we cannot trust it. And it's rework the big problem. So here we trade off an AI that make us wait a little bit more in our tasks, but that limit any rework that you have to do after we go to production. So that is the goal. The goal is to have a quality that allows us to don't have bugs and to trust what's produced. And, the goal is also to give the human being a way to pinpoint the problems. You open the code of nWave, is like, oh, wow, must be a crafter, this. It's so clear, so understandable, so maintainable, that gives you an open window on what is going on inside. It's not something that it's impossible to understand. And I'm happy to wait a few minutes more to have that kind of outcome, right? We are talking minutes versus days.
Right.
Also, there are a few other considerations, Pepe, here. With Ale and Marco, I took the part also of data engineering to check what we were doing against the latest research on academic field, and not only. What we have built with the agents is also how we work with a lot of design thinking. When we diverge and converge and we go in antagonistic review by design, also in what we build. And in nWave, we have put all the research that are out there. Indeed, I've shared on the other meetup a document with all the resources. I will provide you it as well so that everybody can read all the gigantic bibliography that we have behind with all the research on behavioral science, because the fact that people are telling us nWave is slow. Okay, slow compared to what? Slow compared to vibe coding. Good, thank you. And is vibe coding a long run faster? And we know that it's not, because as Marco and Ale said, vibe coding is degrading with drifting, and the rework that you accumulate is something that you cannot even complete because of the nature of vibe coding. So with nWave, there is a sensation at the beginning that is lower, but this is one shot. Bingo, it's done, and then you move on. Also with nWave, what we have done with Ale, because I am neurodiverse, I am affected of dyslexia. So reading all the massive amount of text that AI is prompting me is destroying my brain at the end of the day. And Marco more than once pointed out to me and Ale, hey guys, you should stop to Slack during the weekend at 4 a.m. So go to sleep or go outside to have a party instead of working is not healthy. And so we start to measure about how much are we working with AI. And we have discovered some effect of rewarding with dopamine that is keeping us awake with the brain spinning so fast that we are even not able to sleep. So there are practices that we put in place, and I wrote some time ago an article about that, that is the self-combustion effect with AI that we kept in mind to create nWave. So nWave is designed to create a pace that is sustainable. So the back and forth between agents and human is designed to have a sustainable way of working with AI that you cannot achieve with vibe coding, and you can achieve maybe with other frameworks, but the other frameworks, they don't have guardrail to save your brain long run. And we don't want to burn out anybody. And so, because it's something that we have built for others and for ourselves, we are trying to use ourselves as the guinea pig in the alpha wave of releasing the new releases of nWave to understand are we moving in the right direction? Because we believe in all the ethics that should be regulating the software development as a field where people, they can put their passion and talent on the field without getting self-combusted because of hyperspeed of AI. So this is the final touch also that we have put into the product that we release open source.
Okay. Yeah. So before wrapping up, I'd like to ask you maybe a fun question related to what you just said, Michele. What do you do while nWave is working? Because you may have all these agents doing the work. It could be more or less slow. So what do you do in the meanwhile?
So as Ale told you, me and Ale, we are two passionate martial artists. I have more than 46 years of martial art on my shoulders. And between nWave is doing stuff, I'm reading, multitasking, and doing around 500 burpees a day.
Okay. No, well, so it depends on the situation. So usually while nWave is working, I have another 3 or 4 instances working as well on other projects, obviously. And when I managed to take a break between these 3 projects running concurrently, because I was context switching, it's less taxing if you can detach a little bit yourself. Then I'm also, investing that time, maybe sketching quickly, doing some drawing. So something that can recharge me as I am overlooking 3 or 4 projects. So basically using nWave, it's like you becoming a principal engineer for 3 or 4 different teams that are constantly working. One thing that you can start doing if you really want to be extremely productive, but be careful, as I mentioned before, is as the deliver wave starts, you start the discuss for the next feature. This way you create a full pipeline that, can bring forward features continuously. I don't recommend pushing these too much because it's your mental health at stake. Okay. On the other hand, if you have to push for an important delivery or a demo that is coming very, very quickly, very soon, then you can optimize letting the machine doing the delivery phase and have a review at the end while you are already, discussing and researching for the next feature.
I don't do multitasking. I just do one thing at a time. So I probably more patient than Alex. I even let the tool go in not the fast mode. I click yes every time he asks me permit for things. So I have to stay more focused because I tend to forget the task quickly. But recently I started to watch some video. Yesterday I was watching a lesson by Russell Acuff about thinking, understanding, and learning. So that's what I do.
YouTube and agents, that's our future. Awesome. Yeah, so we are at the end of this episode. Thank you so much for having explained to us what is nWave and how it works. And so I personally invite everyone to try it because I think it's the quality of the output is quite cool. And yeah, there is also a Discord community, right, that you can join if you want to ask for questions to these guys and also like share your experience. Yeah, thank you very much for joining. Yeah.
Remember, it's an open source project and it's free to use. So if you can also contribute or give feedback. So I appreciate if you find an issue and you want to open it on GitHub, I try to, fix and solve as much as I can, as quickly as I can. So if there's an improvement you want to share with others, feel free to create a pull request and then I'll embed it in the main track and give you recognition for that.
Awesome.
In any case, thank you so much, Pepe. Thank you for having me.
Yeah, I'll make sure to put all the links to reach out to you and to the GitHub repository in the description so people know where to find them. Yeah. Thanks again. Bye-bye.
Thank you.
Thank you. Bye. Ciao.